This video will cover beginner questions regarding the topic of one-sided limit. We already solved the one-sided limit using the graph at piecewise function limits and graphing. So now I want to show more algebraic way to find limit. This is the first one. This graph shows y equals 1 over x. What is the limit of 1 over x as x approaches 0 from the right side? The value of 1 over x increases without boundaries, like this. When it grows so large that it cannot be expressed by any number, we call it infinite. Infinity is not a number, nor does it mean that a limit exists. It is just a symbol that expresses infinity. So, if you get a fraction form like 1 over 0 from the right side, in the future, it's good to remember that the value is infinite. Not only when the numerator is 1, but if any positive number is present and over 0 from the right side, this equals infinity. Similarly, if the numerator is negative, over 0 from the right side, the number divided by 0 makes infinity, and the negative divided by positive makes negative. This is the second one. What is the limit of 1 over x as x approaches 0 from the left side? The value of 1 over x decreases without boundaries. So 1 over x approaches negative infinity is the answer. When you see the form 1 over 0 from the left side, it's good to remember that the value is negative infinity. If the numerator is positive number, then divide by 0 from the left side equals infinity, and positive divided by negative makes negative. And the negative number divided by 0 from the left side equals the number divided by 0 makes infinity, and the negative divided by negative makes positive. This is the next question. If we want to solve this problem by drawing a graph, this is the graph of y equals 1 over x minus 1. The limit as x approaches 1 from the right side, the graph goes out without boundaries, like this. The answer is infinity. But if you have a hard time drawing the graph or can't remember it, you can do this. 1 from the right side means it's round. It's 1.000001, right? So this means 1.000001 minus 1. So it's almost 0, but it's a little bit greater than 0. So 0 from the right side. We can rewrite as like this. And then, as you know, this one is infinity and positive. So we have the same answer. This is the next one. We already have a graph of y equals 1 over x minus 1. So we can use this. When x approaches 1 from the left side, the graph goes down. So answer is minus infinity. But I like this way. 1 from the left side means 0.999999. That means x minus 1 is 0 from the left side. So this one is 1 over 0 from the left side. So the answer is negative infinity. So negative infinity, like this. If you're a bit confused, let's use the number line. We already know that the answer is 0. What's confusing is whether it is 0 from the right or from the left. So this is 0 and then 1. And here, it's a little bit less than 1, is 1 from the left side. So 1 from the left side is less than 1. So small number minus big number is negative. This is the next question. The first 4 problems were easy to draw the graphs, but this problem is really difficult to draw the graph. You can draw y equals x squared minus 9 first, and then draw the reciprocal. So when x equals 3 is vertical line, and another vertical asymptote at x equals minus 3, and the 1 is not changed, then everything is upside down like this. Another one. This minimum is minus 9, so it's 1 over minus 9, maybe here. And then minus 1 and minus 1 is not changed. And then the graph is like this, and another side. So that one is y equals 1 over x squared minus 9 graph. When x approaches minus 3 from the right side, like this, the graph goes down without boundaries here. So the answer is minus infinity. Now, I will show you an easy way. Use the number line. This is 0, this is minus 3. So minus 3 from the right side means actually here. So minus 3 from the right side means minus 2.99999. So limit as x approaches minus 3 from the right side, x squared is actually 9, but in fact 8.99999. So this means 8.9999 minus 9, so it's actually 0, but a little bit less than 0 because a small number minus big number. So it's 1 over 0 from the left side. So final answer is minus infinity. Of course, it's the same. From now on, I will try to solve it without a graph. So use the number line here. This is 0 and minus 3. So minus 3 from the left side means here, a little bit less than minus 3, which means minus 3.00001. So limit as x approaches minus 3 from the left side, x squared is actually 9, but in fact 9.00001 is greater than 9. So this value is 9.00001 minus 9, which is 0, but it's actually greater than 0, which is 0 from the right side. So it's 1 over 0 from the right side. The final answer is infinity. Luckily, we already have the graph, so let's check the answer. When x approaches minus 3 from the left side, the graph goes up without boundaries here. Of course, it shows the same answer, which is infinity. This is the next question. We can use the number line. This is 0 and minus 2. Minus 2 from the right side is here, which is minus 1.999999. So limit as x approaches minus 2 plus right side, x plus 2 equals, this x means minus 1.9999, so plus 2. It's not 0, it's actually 0 from the right side. It's a little bit greater than 0. Then back to original, we can rewrite as 1 over 0 from the right side, then squared. Then 1 over, so positive times positive means still positive. So 0 from the right side, the final answer is infinity. This is the next one. Minus 2 from the left side is here, like this. So minus 2 from the left side means minus 2.00001. So limit as x approaches minus 2 from the left side, x plus 2 equals that one, minus 2.00001 plus 2. It's actually 0, but a little bit less than 0. So like this. And then go back to the original. So 1 over 0 from the left side squared. Then this square makes positive, so 0 from the right side. So final answer is infinity. This is the next question. Limit as x approaches 1 from the right, keep the numerator, over x cubed minus 1 can be factored as x minus 1, x squared plus x plus 1. If you don't remember the formula, then use synthetic division. When you put 1 into x, x cubed minus 1 equals 0. This means the denominator has a factor of x minus 1. So it's a synthetic division. 1, 0, 0, minus 1. So it's 1, which means x minus 1. So 1 down times 1, add 1, times 1, add 1, times 1, add 0. So that means x squared plus x plus 1. So here is x minus 1. Then we have the same answer. Then cancel the common factor. So limit x approaches 1 from the right, 1 over x minus 1. And then 1 from the right means 1.00001 minus 1 equals 0, but actually a little bit greater than 0, which means 0 from the right. So it's 1 over 0 from the right side. So final answer is infinity. This is the last one. Do you remember factoring sum over cubes? A cubed plus b cubed equals a plus b, a squared minus ab plus b cubed. So in the denominator, x cubed plus 8, which means 2 to the power of 3 equals, so x is a and 2 is b, so x plus 2, then x squared minus 2x plus 2 squared, which is 4. So back to original. Limit as x approaches minus 2 from the left, keep the numerator, over, that one is x plus 2, then x squared minus 2x plus 4, then cancel the common factor. So limit as x approaches minus 2 from the left side, then 1 over x plus 2, or use the synthetic division. So 1, 0, 0, 8, and make 0 because of x equals minus 2, so minus 2 here. 1 times minus 2, then add, times, make 4, add, times minus 8, make 0. So minus 2 means x plus 2, and this one is 0, 1, 2, so x squared minus 2x plus 4. This one and this one is the same. Then back to the original. Use the number line. 0, this is minus 2. So minus 2 from the left side means here. So minus 2.00001. So actually this means 0, but less than 0. So 1 over 0 from the left side. The final answer is minus infinity. I hope this video has been helpful. Check out the calculus playlist for previous lessons. If you have any questions, leave them in a comment below. Thank you for watching. Please like and subscribe for more.